Ladies and gentlemen, please welcome Matt Hogstrom.
Hey, good morning to you guys. I was trying to think, how many of you guys do presentations for customers and whatnot? You try to come up with a wow, right? How are you going to introduce your topic? Well, we talked about adaptive and responsive with software defined, and I was supposed to be done on the schedule 5 minutes ago. So, what I'm going to do is I'm going to take a 45-minute presentation, and I'm going to consolidate it down to about 20 minutes. And the good news is you're all really smart guys, so this won't take very long. And what I would like you to leave with is, when we talk about software-defined environments at IBM, what we're really talking about is the providers of the IT to the consumers to the IT, and the shifts that are happening in the market. So what I want to lead with is we actually have a new paradigm, because we have lots of situational applications that are coming on board. The time to get a new application up and running is really pushing people. In fact, I just got an email this morning from a colleague of mine, and she was putting together a quick application. She put up a Node-RED application. She hooked it up to Twilio. She had it search for hashtags and then had those pushed out to her phone. She did that in 20 minutes. And she stood it up, it was running, and she had a feed, and she was able to do some playing around with the data. What was the point? It took her 20 minutes to do that. Can you imagine doing that 5 years ago? What kind of system would you have to engineer to do that? What kind of services would you have to stand up to do that? We're in a totally new era of computing, because the demands of getting applications up and running quickly can make the difference competitively of whether or not you're going to be able to deliver on a solution. So with that in mind, we have a traditional model on the left, right? This is our systems of record. Guru talked about this on Monday. And we're moving over to these systems of engagement, these really fast-running apps. In fact, I would offer that a lot of these applications aren't going to be long-lived in many instances, right? They're going to be stood up, they're going to serve a purpose, then they're going to be retired, and then we're going to move on to the next application. And that's that systems of engagement. So the other thing that's happening is things are changing so quickly. The applications are coming in so fast. Our ability to deliver them through traditional means has changed, right? We got increased complexity, we got to go to massive scale, and we have to do it at a rapid pace. So how do we do that? So we have to rethink the architecture that we use to define our data center in terms of how we both wire together the infrastructure as well as how we deliver it to the consumers. And we offer this as a kind of an architecture to start thinking about that. For most infrastructure folks, we'll start at the bottom, work our way up. We have to deal with compute management, right? And I have to do it against a heterogeneous number of resources, right? Whether they're power, whether they're Intel, whether they're Z, whether the hypervisor is KVM, ESX. I've got lots of resources that I want to be able to use to deliver these applications quickly. In fact, I would suggest one other thing to you. We say compute, and I would think, I'm going to actually change this. We're not going to think in terms of compute anymore. We're going to think in terms of containers. Right? The industry's changed, and so I could have a bare metal container, which would be applicable for a database application. I might have a virtual machine container that would contain an application that can withstand the kind of density kind of environment. Or I might have a Linux container, like a Docker container, where I want to put my application into because I need speed and agility. And so I want to be able to leverage those containers quickly. The infrastructure needs to be able to respond to deliver those containers. And the same thing with storage, right? I've got to deliver file, block, object storage. I've got a number of different vendors. I've got a number of different products. How do I deliver those in a consistent way? And the same with networking. And so as we build up the stack, we finally get to the point in the middle where we talk about OpenStack. So OpenStack isn't something you need unless you're trying to deliver a software-defined experience in the environment. And as you'll see later, it becomes even more important as we start talking about hybrid cloud. And so what we're trying to get to, and what we will get to, is take all of this tribal knowledge that we have in the data center into a storage silo, and the network silo, and the compute silo, where we've got policies that are in people's heads, they know how the infrastructure runs. We want to reorganize that as we move over to the right into a streamlined delivery model. We want to start delivering and cabling together and racking our compute and our storage in a very scalable way so that we can get to these levels of efficiency in the environment. So, software-defined environment isn't about just the infrastructure, right? When we talk about infrastructure, it's easy for us, right? We think in terms of boxes, we think in terms of hypervisors, we think in terms of how we are going to virtualize these things and make them available. But those are the folks at the bottom. Those are the providers. That could be you as an MSP, as a CSP. It could be your customer that's running a data center that wants to transform and become a provider themselves to internal IT. And then I also talk about the software-defined consumer. The software-defined consumer, he doesn't really care about the infrastructure. What he really cares about is, like my colleague, I want to get this thing stood up in 20 minutes, and Jimmy crack corn, I don't care how you do it. I want to get the application up and running. So how do we marry these two together? How do I take the consumers and let them build their applications in a way that'll scale? And how does the provider understand these applications as they're coming in? Because they're coming in so much faster, we don't have time to size them and scale them like we used to. So the infrastructure has to be much more dynamic in order to deliver on this shared infrastructure, all these applications in the environment. I'm going to go ahead and skip this slide. And so how do we get to this kind of delivery model where we have uniformity? And we have to do it through open standards. So back in 2009, IBM started delivering a set of technology called the IBM Workload Deployer, and then that turned into the Pure Application System. How many of you heard of the Pure App System? Okay, some of you? And the whole goal of the Pure App System in IWD was to create patterns. It was to allow developers to express the workload in a way that could just be deployed in the environment and run. That particular model, customers loved. They like this idea of automating and being able to repeatably deploy an application and version it over time. But what we found is a lot of people viewed what we did as proprietary. And so they were waiting for some kind of open standard to evolve so that they could start depending on that open standard and leveraging it, because they wanted to avoid vendor lock-in. And that standard is OpenStack. In the networking space, we have Open Daylight, Open Power, and moving over to the Standards Council, Tosca, which is the basis for the hot format in OpenStack. But it has to be based on open standards. So think about today. How does VMware deliver a hybrid cloud? It's VMware on one side, VMware on the other side. That has to be uniform on both sides. That's not really a scalable model depending on your cloud provider, right? You want to go over to Amazon. Think of Microsoft and Azure, same thing, same stacks on both sides of the equation. So if I want to actually have choice of cloud, and I want to reuse my tooling, and I want to limit the amount of changes that I have to make, what I really want is an open standard that'll work over there on that external cloud, and I want a standard that'll work on my internal cloud. And OpenStack delivers that. So we have IBM Cloud Manager with OpenStack is kind of our core offering that we have in that space. And the reason you want OpenStack, again, is for this kind of leveling of the playing field for your APIs, right? For the consumer is really who it's for. And it's not just, our Cloud Manager with OpenStack isn't just OpenStack, right? Anybody could go out to the community and harvest it. So we take OpenStack as a paradigm. The APIs are sacrosanct. We don't mess with those. The behavioral model is sacrosanct. We don't mess with that. But there's a lot of room for improvement in terms of capability in OpenStack. So for instance, IBM includes a set of capability around being able to do resource management. All right, so we start talking about the cloud provider has all these applications coming in. I've got some that might be data analysis. I've got some that might be web tier. I might have some that's, some application I don't know. It's a set of VMs. So how am I going to manage those? PRS actually allows a couple of different interesting capabilities. It lets you specify where is the workload going to go. If I'm going to deploy a workload that's got 20 different nodes, can I put them all on the same box? Or do I have to put them all on different boxes? What's my policy in terms of how do I want to place those in the environment? Maybe I'm actually interested as a provider that I want to try to limit my software usage, so I actually want to pack as many software VMs and containers and whatnot onto the smallest number of boxes. So there's a management within that provider level, and there's also availability concerns from the developer up above. So how do we communicate those things? So we talk about this pattern development, and if you start in the upper right, you'll see what we call heat templates. They're actually called hot documents, heat orchestration templates. And what these are YAML-based source code documents that describe a workload. And what do I mean by that? So let's say I'm standing up a web application, and I want to scale that out. In that hot document, I can specify the container that I want, the automation that I need in order to stand up the application. I can specify how many nodes I want at a minimum, how many I want as a maximum, and I can specify policies around anti-colocation or colocation, and then I can deploy that into the environment. This is my means of beginning to communicate the desire of the workload down to the infrastructure. So it's not just start a VM and allocate some storage. It's here's my set of VMs, my workload, and here's how I want them to be managed in the environment. So the infrastructure now has information about the workload so that it can take corrective action in order to meet the needs of the workload. And then as we move over to the left, we've got kind of the pattern designer. That document gets fed into heat. And here's the interesting and valuable thing about OpenStack. I talk about an abstraction. If you want to deploy your application onto Amazon, or you wanted to deploy your application onto Software, or you wanted to deploy your application to an on-premise, OpenStack, as you can see here, allows me to actually deploy to all those different environments using the same APIs, same tools, et cetera. That's the real power of this. So let's look at this in action. Looking again in the upper right of the screen, what I do first is I select an application. And I'm selecting that application out of, say, Cloud Orchestrator, where I've got a whole list of patterns, a whole list of workloads. Think about developers in an organization. I want a set of Node.js nodes to scale, and I want a set of policies, et cetera. We want those to be repeatable. We want those to be shareable. They're in a catalog, and the developer just grabs that workload. Then he starts marrying his application up to it. And then in 2, we generate the pattern, and we deploy it into the environment, and we hand it off to the heat engine. The heat engine then does the actual work of create VM, allocate storage, move things around. And then finally, the application's auto-deployed, it's auto-scaled, and then we start the whole process over again because applications aren't static. We want to change them over time. And so, again, the idea here is these are the consumers deploying their specifying their application, giving a set of constraints on it, deploying it into the infrastructure, and then being able to iterate on it. And doing all that in 5 minutes or less, or 10 minutes or less. This is a really powerful paradigm, and the interesting thing about it is you see that this approach is happening in the open community. Amazon has an approach called CFN, right, Cloud Formations. OpenStack has it in the heat format, in the hot document, but the OpenStack is open so we can rely on, we don't have to rely on a particular vendor or proprietary protocol. We're able to use that, spread it around, and reuse it across a lot of different environments. And this is effectively what it looks like from the top down. I specify a pattern. That pattern turns into infrastructure, virtual instances, Docker containers, or bare metal containers, and then it gets hosted on the infrastructure. Now, also underlying all this, there's going to be a big data panel. You need storage. Now, you don't just need storage, right? You could just set up object storage, right? And I could put in images, I could put in photographs, I could put in movies. But once that data is in there, how do I manage it? Does it stay there forever? Does it get managed off the tape? Do I delete it after a period of time? Do I take it off of SSDs and move it onto HDDs? Am I going to have to manage all that myself? No, you're not going to want to manage that yourself. If you're scaling up to a petabyte or more of shared infrastructure, whether it's file, block, or store or object, you actually want the infrastructure to manage that. You want it to be policy-based. So you want to set, for this set of objects, if they haven't been referenced in 30 days, move them off to slow disk. And if they haven't been referenced after 90 days, let's move them off to LTFS or migrate them out into the cloud for the lowest cost environment to store that data in. And the point here is, with the policies, availability, et cetera, and the usage of the infrastructure, like I said, it's happening so fast, you've got to have policies. Consider this afternoon, many of you are going to fly home. You get on the plane, and you're sitting in the back, and the plane gets you to your destination. Does the pilot actually fly the plane? No, actually he doesn't. The plane's got way too much information coming in terms of speed, turbulence, altitude. The pilot actually just sets a vector and he sets an altitude and he guides that plane to where it needs to go. He effectively sets a policy, and the infrastructure, the plane's computer systems and control surfaces actually get the plane to the destination. And that's what we're talking about in the software-defined environment. You want the policies to manage your infrastructure. You're not in a position to be able to manage it, especially with this increasing velocity of applications that you're going to put into the environment. So with our elastic storage capability, we have a kind of a storage substrate that enables this kind of capability. Again, multiple file access protocols, multiple storage formats, and policy-driven. And policy-driven both from on-premise, also out into the cloud. Another aspect of the software-defined environment, and this gets back to pattern-based deployment, is the network. Now, SDN is a big topic. There's a lot of churn about what SDN really is. But at the end of the day, when you think about it, I'm probably going to want some firewalls. Those are some basic services, right? Security groups. I may want to add some intrusion protection devices. I might want to add some routing or content management, load balancing, things of that nature. We're at the point now where I can start specifying those capabilities right alongside the workload. So when I specify the workload and I deploy it, I can give network information in order to construct this kind of virtual network environment for the application to host it, and a set of policies that go along with it. And the very cool thing is, if I'm setting firewalls and I'm setting policies for routing, et cetera, I'm associating that with the application. So when I'm done with the application, I just go poof, and it's gone. I don't need it anymore. And that gives me an opportunity. I don't have to put all of my rules and all of my configuration and all of my management in a core set of capability. I can actually distribute that now with the applications, and the application can specify those when they're deploying them into the environment. Again, policy-driven access into the environment from the consumer, policy-based actions and management from the infrastructure on the way up. So just to net this out, software-defined environments is the next generation of automation. Everything that I'm talking about here is possible today. You can specify your workload, you can version your workload, you can manage your network or specify your policies, you can do it for your storage, and those policies get pushed down into the infrastructure, and that infrastructure then manages to those policies. And in the future, IBM is coupling that with hybrid, so that we can manage not only on-premise, but we can manage off into an off-premise environment. In fact, consider this scenario. Maybe it's not an off-premise provider, right, like Software, right? Software has a set of hybrid capability that I can connect to from on-premise. But maybe in my particular organization, maybe I'm a retailer and I've got lots of branch offices, or I'm a bank, or I'm a telecommunications company. And I want to be able to get to this automation, push these workloads out and distribute them across a broader area. The software-defined environment gives you that framework. It gives you that foundation so you can establish a set of automation that's part of an open set of standards, and you can scale your infrastructure, you can repurpose your infrastructure, and you can deploy your applications with policies in order to meet the needs of the organization. So here's a quick example of this actually working in practice. We have a large bank in China, and they were having a problem with doing some data analytics. And what they did is we ended up using DataStage to do the ETL processing, and OpenStack to dynamically create the workload that was going to process those and analyze that data. And they cut down their time dramatically. I think it was an order of magnitude of about 3x. And they did it because it was automated, and it was policy-driven, and it was the environment, the infrastructure, responding to the demands of the workload. Now, software-defined environment, you say, okay, where do I start? Do I have to go restructure my entire infrastructure to do this? Well, no, actually you don't. The beauty of the SDE is you can take it in slices. So in this particular case, we had a large US retailer. They had a problem with storage. And their problem was it was too difficult to manage. They were looking for a solution that would allow them to request-driven provision the storage, to automatically manage the storage, and they wanted to do it based on an open standard so that they could plug different vendors in on the back end and not rely on one particular vendor's way of doing it. They wanted flexibility. And so what they ended up doing is they took OpenStack Cinder, and that's the storage abstraction in OpenStack, which gives you, create volume, delete volume, et cetera. And behind it, they put an XIV system, which plugged right into the OpenStack framework, just like EMC would plug into it, just like Elastic Storage would plug into it. And so the consumption API is the same, and they were able to turn around storage to their development community dramatically faster than they could before, and with the XIV, they were able to get a self-managing, self-tuning environment, which reduced their administrative cost of having to manage the storage. So again, back to this policy-driven kind of infrastructure. So from our perspective, just in the data center is not enough. And so to measure the software-defined environment, the reality is 70% of the organizations are looking at hybrid. They're looking to reduce their OpEx. They're looking to reduce their CapEx. How do I rent the equipment for when I need it? And so they're looking for leverage. How do I optimize my usage of the infrastructure without the investment, right? Not a story that's unfamiliar to many of you right now. And so what do I want in the hybrid environment? Well, what I really want is I want seamless connectivity. I want to actually be able to take this application that I developed and I built. Maybe I have a developer, her name is Maureen. And Maureen deploys this application on premise. It's working great. And all of a sudden, it turns out it's so great that she's exceeding the capacity they have on premise, and they decide they're going to go ahead and put that out into the cloud. Well, does Maureen want to have to go back and retool and rejigger and work on her application? No. What she really wants to do is look in her console and say, oh, you know what? I'm going to deploy this from, instead of region A, which is on premise, I want to deploy it on region B. And Maureen simply changes the pool that she wants to deploy it into, and using the same tooling, the same hot documents, the same images, she's then able to deploy that out into the cloud. And so we have that, this particular capability is working today in the GA versions of the IBM products that support this SDE. So Maureen actually deploys on premise, then we have Maureen deploy off premise and talk back to the database that she has back at home. Imagine Maureen trying to do that 5 years ago. How much engineering would have to go into that? And Maureen is all doing that by communicating her workload needs, and the infrastructure team can also provide a set of controls or governance as needed, depending on the application. So in the hybrid environment, two things are happening. We have what we consider to be two classes of applications. If you look from right to left, out on the public cloud, applications are being built in cloud native form, right? They assume everything's going to fail. They have an infrastructure around them. They look for scale out. They look for a set of services. They're a very different paradigm than the applications that were built 5 years ago, 6 years ago, 7 years ago. That thinking is trying to make its way into the organizations. Developers and enterprises want to be able to do that. The enterprises aren't quite ready to move that quickly. And then on the other hand, at the bottom, from the right or the left to right, I got IT and infrastructure, and those guys want to move into a cloud, so they transform what they have into this consumption model of API driven. Then they want to go to hybrid cloud, and then maybe they want to go to public cloud. And so we have this kind of two different directions of the application development process, and the SDE can actually serve them both. So it's not a trade-off of one particular application workload development model. I actually have an environment that will allow me to support this bidirectional development model and application programming paradigm, which gives me tremendous flexibility, especially as a service provider, because I'm not having to rebuild my infrastructure for these applications. Now, does it all have to be cloud native? No, and that's what this is really pointing out. I can take my traditional applications and begin moving them into this software-defined environment, and they can be hosted just like they are today in a virtualized environment. So I can now get the opportunity to start deploying my applications and migrating perhaps some of my systems of record into the shared pool. And that's the goal. Again, it's back to the efficiency, the reduction of our capital, the reduction of our administration, the reduction of the people time through automation. So on-premise, right, we want rapid access, low entry, highly elastic, off-premise. And on-premise, we want it to be customizable. In fact, I got a heterogeneous environment, so I can't just pick one thing. So we need something that will allow us to do both. So what are we doing in this space? So this is actually a really good story. So we have platform computing is big data analytics, HPC product that IBM has. A large number of customers, financial institutions, et cetera, that use it to mine data. We had many customers, oil and gas, financial, and what they want to do is they want to crunch data, but you know what? They only want to crunch it for 10 days out of the month. Well, what did they do before? They had to build for whatever that maximum environment was. Now, we have many customers that are starting to push that data out into software, and then they just pay for what they're using for the period of time they need it. They only need it for 10 days, fine. If they need it for 20 days, fine. And this gives them an opportunity to, again, adjust their elasticity of consumption and, again, reduce their capital, et cetera. And we want that experience to be seamless. So I want my data to move where I need to in terms of processing. And our Elastic Storage product has that capability built into it so that we can start moving data across the network to where it's needed for doing the compute. So finally, the public, private, and hybrid cloud on software, we see really a couple of models evolving. One, we see there's on-premise, and we see where customers want to get into the cloud, but they want a private environment where they can create a VPN between that external set of IT resource and the internal set of IT resource. So they exchange data, they can connect applications without a lot of issue, but they have the safety of being isolated from everybody else out in the cloud. In fact, we have offerings in the space of hosted managed, where effectively we deliver a set of compute resource on software with OpenStack on top, so we have the same consumption API, but all the infrastructure is managed. The disk drives are monitored, the physical systems are monitored, 24/7, and anything that happens in that vein, you've offloaded that operational aspect to software because you're really concerned at this point about starting to consume it, right? The lower priced offering is customer wants to actually manage it themselves. They want to be involved in this disk drive's going bad, or I want to change the pool or the allocation of resource, and I want to be more hands-on for whatever reason. So we see that model evolving as well, and then of course in the public cloud. So to kind of sum it up, the other piece that I talked about is the consistency, and it's not just API consistency. The other consistency that you want is what we refer to as foundational services. It's not just about compute, storage, and network. Quite honestly, those are kind of baked. Some of them are continuing to evolve a little bit, but we know how to do those. The foundational services are things like auto-scaling. I'm going to depend and expect that the infrastructure will do that for me. I want monitoring, and I want the infrastructure to do that for me. I want to archive my data. I want the infrastructure to do that for me. So it's not just the API to create the IT resources, but it's the behavioral model around those foundational services that are now expected to be part of the infrastructure. And so we see that at the very bottom we have what we call the open cloud platform, which builds out of that infrastructure piece. Then we have an operations element, and then we have the development and the DevOps that get married on top of that infrastructure. And that's how we're looking at the world going forward. So to close, the world's changed. Providers want to transform into cloud providers, not just IT providers. We need a way of doing it in an open fashion so that I don't get locked into a particular vendor's proprietary way of doing it. And it gives me some freedom of motion, which with the pieces of infrastructure that I want to actually put in underneath, whether it be a VMware infrastructure or a KVM or maybe Docker containers. We need that infrastructure to be consistent. We need the APIs to be consistent, and we need those foundational services to be consistent. Because the goal is for the consumer, the application developer that wants to be able to deploy their application very quickly and have it managed against a set of policies, I have to have a set of standards. And IBM is focused on using OpenStack, the open technologies, extending, enhancing without violating the APIs or the behavioral models, and delivering that to customers so they can build out their software-defined environment. All right, 45 minutes crushed down to 20. Be generous when you're rating me. Green is good. All right. So Neil, I'll turn it over to you.